Hello everyone, welcome back. Today I'm going to give an introduction on design of prestressed concrete section by Flexure. Usually in design of beams, we need to design the section both for flexure as well as for shear. In this module, we are going to design the prestressed section only for flexure. This is purely for the flexure. Design of prestressed concrete section is similar to what we use to design in reinforcement cement sections with some of the prestressed concrete specifications in that. The prestressed concrete section should satisfy the permissible limit specified in Indian standards both at the transfer stage and as well as a service load. So let's see. Under that, the first one is minimum section modulus. Prestressed section under the action of flexure should satisfy the limits of stresses at the stage of transfer of prestressing and service load. The general critical combinations considered are: the first one is the maximum prestressing force at transfer together with minimum moment sustained by the section. What is the first combination? It is minimum pre-stressing force at transfer stage plus minimum moment sustained by the section. This is one combination. The next combination is the minimum pre-stressing force after all losses in combination with maximum design moment for the serviceability limit state. The second combination is minimum pre-stressing force after all the losses plus maximum design moment for the serviceability limit state. These are the two combinations: maximum plus minimum moment, minimum pre-stressing force plus maximum design moment. The next is the design formula for section modulus to keep the stresses in all loading stages within the limits is given. So it is given by the formula for has ZT as well as ZB. ZT, you know, it is a section modulus at bottom, at top. This is section modulus at bottom. This is for a transfer stage. This is for a working load condition. ZT is greater than or equal to MQ plus 1 minus N into mg whole divided by FCW minus eta FTT. ZB is, it should be equal to or less than mq plus 1 minus n mg whole divided by eta FCT minus FTW. Okay, where we should be familiar with these terms while solving the flexure problems, where FTT is permissible tensile stress in concrete at transfer, FCT permissible compressive strength in concrete at transfer, FTW is permissible tensile stress in concrete at working load, FTT permissible compressive stress in concrete at working load. Okay, these are the terms we should be knowing. Next is pre-stressing force. The expression for minimum pre-stressing force is P equal to A into F inferior into ZB plus F superior into ZT whole divided by ZB plus ZB. where F superior is FTT minus mg by ZT. F inferior is 1 by eta into FTW plus mg plus mq whole divided by ZB. Eccentricity is E equal to ZT into ZB into F inferior minus F superior whole divided by A into F superior into ZT plus F inferior into ZB. These are the formulas to be used while we will be using while doing the design. So for a minimum pre-stressing force, this is a formula. It consists of F inferior as well as F superior, where F superior is equal to this much and F inferior is equal to this much. And also the formula for eccentricity is this one. So these are the formulas we should be thorough with for the design. Next, limiting zone for pre-stressing force. It depends upon two critical conditions. That is, the first condition is maximum pre-stressing force plus minimum moment. That is one condition. The second condition is minimum pre-stressing force plus maximum design moment. These are the two critical conditions the limiting zone of pre-stressing force is dependent on. For these two conditions, minimum eccentricity value will be calculated both at the top and at the bottom for the provision of cable profile over the length of the beam. And those minimum eccentricity equation will be given by the following four equations. I will just show you that. This was just general thing about the limiting zone, but let me read out. The pre-stress along the length of the beam is generally adjusted by varying the eccentricity of the pre-stressing force. This practice is generally used in post-tension beam by using curved cables. In case of pre-tensioned members, tendons may be deflected by using deviating devices fixed to the mold before casting. After having once determined the magnitude of the pre-stressing force for zone force bounded by the upper and lower limits expressed as function of minimum and maximum moments, sectional properties, pre-stressing force and permissible stresses. So let me show you the equations. The limiting zone is defined by four equations. That is eccentricity is less than or equal to minus ZT into FTT whole divided by P plus ZT by A plus M minimum by P. This is equation 1. The second equation is E is less than or equal to ZB FCT whole divided by P minus ZB by A plus M minimum by P. This is second equation. The third equation is eccentricity is greater than or equal to minus ZT FCW by P plus ZT by A plus MD by eta into P is the third equation. Fourth one, eccentricity is greater than or less than minus ZB FTW by P plus ZB by A plus MD by eta into P is a fourth equation. Here in these equations you can observe a few things, that is the first equation as well as third equation is having negative, is in terms of negative terms, negative values, okay, but the second one as well as the fourth one, it is for positive. uh, I'm really sorry, this fourth one should be positive. Okay, I have corrected it now. It is positive value. The second one and the fourth one is positive. The first one and third one is negative. That is one part. And the first one and the third one is for the top sections. So here we are using ZT, ZT, and it is for FTT. Here FTT means it is we are using permissible tensile strength, tensile stress at transfer stage. The third one is it is negative, it is for the top section, but here we are using FCW. FCW is it is a permissible compressive stress in concrete at working loads. Like that, here also you can see ZT. Next is Z, that is for a second and fourth equation. For second equation, it is for a section modulus at the bottom. FCT is permissible compressive stress in concrete at the transfer stage. Here also we will use ZB. Like that, for the fourth one. Here for the fourth one, just now I have corrected, it should be a positive, it should be negative, so change it. See here, it is for a section modulus is for a bottom section. FTW is a permissible tensile stress in the concrete at the working loads, and here again it is ZB. These small things we should remember while by hitting or while remembering these equations. So be careful with these equations. It is bit complicated in terms of while writing the notations, you may go wrong there at that stage. The next thing is it is about, let me show you this, it's this cable profile. I had mentioned that the limiting zone depends on the factors or conditions. For these two conditions, the minimum eccentricity value will be calculated. Just now I have mentioned about it. It is calculated both at the top and at the bottom for the provision of the cable profile. Okay, and why we require this is for the overall length of the beam, cable profile over the overall length of the beam. And the important thing is here just now you saw some profile, okay, cable profile, you have seen it, or you have seen a curve. How they have plot that is, we have the minimum eccentricity equation that is given by equation 1 2 3 4 like that, but for plotting this curve we will be using only the second and the fourth equation. We just come back here and check what is the second and fourth equation is. It is the positive value, okay, it is a positive eccentricity value we will be using to plot those curves. So I will read out this. The curves represented by two of these four equations are given in the figure below. Positive eccentricities are plotted below the centroid of section. Okay, we will be using the positive eccentricity, that is equation 2 and 4. In case of prismatic members with a constant prestressing force, permissible tendon zone is controlled by equation 2 and 4. here we will be getting the curve like this. This is the center line of the beam. It's first of all, it's a rectangle section. It is having a center line of, we have marked the center line of the beam, and this is a limiting zone. This portion, whatever hatched portion you have seen, it's a limiting zone here. Okay, this is about the introduction of design of pre-stressed concrete section. Hope you have understood this. Thank you.